This is KV question paper set 2. Huh? Yes. This is a often asked question. On seeing this, you can easily understand. This is in your book as a exercise, it seems, right? In attempt to demonstrate the electrical conductivity through an electrolyte, following apparatus has been set down, right? Which of the following statements are correct? It may be singular or plural, right? So what is it? Just observe the setup here. Here, dilute NaOH solution is taken as electrolyte, and there is a rubber cork. This is iron nail, and the two nails are connected to positive and negative of a battery through a switch and bulb. Right? Okay, this is a experimental. The bulb will not glow because the electrolyte is not acidic. Because it is NaOH is a base, that is why they had given option. The bulb will glow because NaOH is a strong base and furnishes ion for conduction. The bulb will not glow because the circuit is incomplete. The bulb will not glow because it depends upon the types of electrolytic solution. Right. Here, uh, this is a simple experiment we will do in our ATL. Listen here. Right. So what we will do in our ATL, the students will do like this. They will take a battery, right? They will connect it to the switch. They will connect it to the motor, and the other end will be connected to the battery. Here in this motor, whatever it may be, a fan or siren, whatever it may be, they connected, but the switch is on, the siren will do. You remember, these are the simple experiments we had done in our childhood, right? So now, same setup is given here, right? The same setup is given here, but the thing is, apart from switch, here they had added one more thing. That is a battery. They had added this one in the part, the whole setup. They had added the school whole setup here. Purida? So the current will come over here, and if there is any conduction, it will pass through that, and again the circuit will be closed. There is no conduction, the circuit will not flow. Conduction, in the sense, conduction here should takes place through the electrolyte here. This is electrolyte here, right? So how does the conduction will take place? The conduction will take place through ions, right? If there is ions, the conduction will take place. So they had filled with the electrolyte called NaOH. So NaOH provide Na plus and OH minus ions, right? Because of the presence of ion, the electricity will pass. So the right answer is the bulb will glow because NaOH is a strong base and it furnishes ion for conduction. So the conductivity does not depend upon either the solution is acidic or basic, right? Either the solution are acidic or basic, the conductivity does not depend upon this one. It needs only one thing. What is that? Ions, movement of ions. Ions must be there, and the electrons move through the ions. I have a question here. The pure water does not conduct electricity. Pure water. But the tap water conduct electricity. How? Yes. No, in pure water there are no ions. No ions. In tap water there are impurities. The impurities serves as ions. So that conduct electricity. So the answer is because of the presence of ion, the circuit closes and it conduct electricity. Two options they had given, but second option is the right. What we marked is the right answer. Right? Answer 2 only is the right answer. Right. Why ionic compounds are hard crystalline solids? Yeah. Four options are there. Ionic compounds. First of all, what is an ionic compound? We have seen covalent compounds, ionic compounds, and coordinate compounds. Do you remember? Covalent, ionic, or electrovalent coordinate. These are the types of bonds, and because of these bonds, the compounds formed are called specific compounds. That are covalent bond. The compounds which are formed through covalent bonds are called covalent compounds. The compound which formed through ionic or electrovalent bond are called ionic compounds. The compounds which formed through coordinate bonds are called coordinate compounds. Right? That are called coordinate compounds. Right? So the ionic compounds that are due to the presence of these bonds, these compounds are called like this, right? So ionic compounds, among this compound, the ionic compounds are hard and crystalline. Why? That is a question here. Due to the strong force of attraction between the positive ions, due to the strong force of attraction between the negative ions, or both A and B, or due to the strong force of attraction between the molecules, right? Here, this will be the right answer. That is, due to the strong force of attraction between the positive and negative ion. Now let us move to the next question here. Get it? So, which among the following statements are true? Exposure of silver chloride to sunlight for long duration turns gray due to. First, for this kind of questions, you have to write the formula for this one. That is silver chloride in the sense AgCl. What they say is this exposure of silver chloride turns turns gray in long duration. So AgCl when exposed to sunlight, it will become Ag plus Cl. It will decompose, right? So this is gray in color. This is gray in color, right? That is why the silver chloride turns to gray. They had given the option as formation of silver chloride by formation of silver by decomposition of silver chloride. This is the right option. Sublimation is not the right answer. Decomposition of chlorine gas from silver chloride. So that is also we can say na, chlorine gas has been evolved. So adanala chlorine has that also we can say oxidation of silver chloride is not the right answer. So option 1 and 3. Option 1 and 3 is the right answer here. Decomposition they are not accepting. Huh? Yeah. So for decomposition we need not to accept. So for decomposition of chlorine gas from silver chloride. That's also right one. Okay. Anyhow, we did not accept this one. So the first only is the right answer. Clear? But this is also right answer. But anyhow, we can go with the board. Okay. Next question. Yes. Equal volumes of hydrochloric acid and sodium hydroxide. So what is the formula for hydrochloric acid? HCl. Sodium hydroxide? NaOH. Solutions of same concentrations are mixed, and the pH of the resulting solution is checked with the pH paper. So listen here, equal concentrations, that is most important. Equal concentrations, same concentrations, right? So the number of ions in the acid is equal to the number of ions in the base, right? So what happens then? Here, what will be the, let us complete the reaction. The reaction will be NaCl plus H2O. So acid plus base, use salt and water. Right, this is a neutralization reaction. The pH of the resulting solution is checked with the pH paper. What would be the color obtained? So they had given the color, right? What would be the color obtained? That is what we have to give, right? Red means what? Red is 0. So 0 means it is highly acidic in nature, right? Yellow means it will be moderately acidic. It is between acidic and the base. Yellowish green, that is milder than the prior one. And the blue, this is strongly basic. Can you understand? Last guys, right? This is basic. Right. Can you tell me what will be the color of the pH paper if we dip the paper in the resultant solution? Yeah, yellowish green is a answer here. The same thing. Neutralization takes place between the HCl and NaOH and pH will remain neutral. Hence yellowish green zone in the pH people. Right? That's it. Next question. That is for physics it seems, right? Yeah. This is our part. Okay. Hmm. So observe this question clearly, right? Metal, how it reacts with air, how it reacts with water, how it reacts with dilute acids, right? Gold does not oxidize or burn, does not react with water, it does not react with dilute acids. Sodium burns vigorously to form oxide with air. With water, it gives a violent reaction. With dilute acids also it gives a violent reaction. Zinc burns form to oxides. It reacts on heating with water and it reacts to produce hydrogen with the dilute acid zinc. Platinum does not oxidize or burn, no reaction, no reaction. Now platinum jewels are available now. Why? What's the reason we are using platinum as a jewel? Yeah, they will not react with anything. That is why, and it will give you a glossy finish. That is okay, right? Now let's get into the question. Which of the above metals are likely to be obtained in the pure states of the earth crust? Pure states. Pure states means it should not react with the air or moisture, right? Gold will not react with the air, do not oxidize or burn. With water also it will not react with the dilute acids also it will not react. And here platinum does not react with the air or water or acids, right? Sodium and zinc, these are all reactive metals. As we know, sodium belongs to first group, right? And zinc belongs to D block elements. This is S block element, this is D block element. So these are all reactive, right? But gold and platinum are unreactive. That is why these two are available in the directly available in the earth. Okay, then hydra. Yes. A student studies acetic acid is a saturated compound. Acetic acid is a saturated compound. The structure of acetic acid is shown, right? How it can be, why acetic acid is classified as a saturated compound? Good, good. That's a good question, right? I told you already that saturated compounds means they will have single bond. I told you, na? Single bond. If there is a double bond, it is an unsaturated compound. But the acetic acid is a saturated compound, even though it is having double bond here. This is CH3COOH, right? This CH3COOH, they draw the structure like this. How this can be considered as a unsaturated, saturated compound, even though there is a double bond? Yes, they had given. There is a single bond between the carbon atoms. There is a double bond between the carbon oxygen. Double bond means unsaturated, so this is ruled out. There's a single bond between carbon and hydrogen atoms. This is between two carbon atoms. This is between carbon and hydrogen atoms. Single bond between carbon and hydroxide diatom. This is the hydroxide. So this is the single bond. The answer is there is a single bond between the carbon atoms because saturation and saturation deals with the bond between the carbon atoms. If it's C bond C, it is called as saturated. If it is C double bond C, so if it is C triple bond C, unsaturated. So this is the reason. That is the carbon-carbon bonds decides the unsaturation or saturation. Here, there is a single bond between the carbon and the carbon, right? And this is considered as a functional group. So this is the reason that why acetic acid is considered as a saturated compound. Is that clear? Any doubts? Right. Yes. A metal carbonate reacts with a solution X, which forms a salt, water, and gas Y. What are X and Y? Metal carbonate. Any metal carbonate we can take. Let me take calcium carbonate. CaCO3 calcium carbonate reacts with the solution X. Sorry. It reacts with the solution X. It gives a salt and water and carbon dioxide, because being a carbonate salt, carbon dioxide can only come from here, right? So what is the salt and what is the salt is gas is Y they had given, gas we had identified as Y. So forms the salt, water and gas. So what is the solution which used here? Right. So listen here, the carbonates usually liberates carbon dioxide when it is treated with an acid. Right. So let us check out the options here. Sodium hydroxide, carbon dioxide we get found out. So this is the base, sodium hydroxide is the base, sodium hydroxide is the base, it is not a hydrogen. This hydrochloric acid, carbon dioxide, hydrochloric acid and hydrogen. Hydrogen is not there, it is carbon dioxide. So it will be hydrochloric acid and carbon dioxide. So it will be HCl. It will be HCl. And what will be the salt here? CaCl2, calcium chloride will be the salt here. So this will be the reaction. Clear? So as calcium salt when treated with an acid gives H2O plus carbon dioxide plus the respective salt. The answer is HCl, carbon dioxide. Okay. Assertion reasoning, yes. Yeah. The reaction M1O2 plus 4HCl gives M1Cl2 plus H2O plus Cl2 is an example of redox reaction. So what is in the redox reaction? Reduction and oxidation should take place simultaneously. What is reduction? I'll give you a simple example. Reduction in the sense, yeah, that is your view. Now we can change the definition as decrease in oxidation number is reduction, right? Decrease in oxidation number is reduction. Opposite work, increase in oxidation number will be oxidation. That will be oxidation, right? So let us find out the oxidation number of manganese here. So manganese, this is minus 4 oxygen. Each oxygen carries minus 2 charge, 2 oxygen. So it will be minus 4. So the oxidation state of manganese will be plus 4 here, right? Let us check out the manganese here. It is a 2 chlorine minus 2. So the oxidation state of chlorine will be plus 2 here. So what happens? The oxidation state of manganese has reduced from plus 4 to plus 2. So what has taken place here? Reduction, because decrease in oxidation number, reduction takes place, right? So reduction has taken place here, right? In the case of hydrogen, look at here. Here H plus Cl minus, so plus 1. Hydrogen is plus 1 here. But here in the case of oxygen, here the hydrogen, the charge of hydrogen is 0. Here also it is getting reduced. How it is possible? Here also it is getting reduced. So this goes from plus 1 to 0. So what happens? Reduction happens. But on the other hand, we can say that oxygen is added to addition of oxygen has been takes place in the hydrogen. So that we can say that it is an oxidation reaction. Okay, instead of taking this concept regarding the oxidation part, they had taken the your concept, the 10th standard level of the Van Dam. So we can leave all these things. Simply addition of oxygen or hydrogen will take here. Huh? That will be a simple thing for you. அதான் உங்களுக்கு ரொம்ப ஈஸியா இருக்கும். இது இன்னும் தலை சுத்தி வருது. Okay. Simply we can say that. Simply we can say what happens in the Mn? இங்கே ஆக்சிஜன் இருக்கு. சரியா? இங்கே ஆக்சிஜன் இல்ல. So here what happens? Oxygen has been removed from here to here. So what happens? Removal of oxygen, reduction. Here HCl water is not there, but water is added here. So oxidation. So it is a redox reaction, right? Next, in this HCl is reduced to Cl2, whereas MnO2 is oxidized to MnCl2. Right? HCl is reduced to Cl2. No, HCl is reduced. HCl is oxidized. Now, hydrogen is oxidized here. So this is not the right answer. Hydrogen is oxidized here. And MnO2 is reduced to MnCl2. So this word differs here. That is MnO2 is reduced. Mister, yaar udda? Oh, thank you. Thank you, sir. Right. So in the இடத்துல what happened here? This is oxidized. Actually, hydrogen, water is added. புரியுதா சொல்றது? ஹைட்ரஜன்ல என்ன ஆட் ஆயிருக்கு? தாமரை புரியுதா? வாட்டர் ஆட் ஆயிருக்கு. ஸோ அதனால இட் ஹாஸ் பின் ஆக்சிடைஸ். இங்க மேங்கனீஸை பொறுத்த வரைக்கும் ஆக்சிஜன் ரிமூவ் ஆயிருக்கு. தட் இஸ் ரிடியூஸ். ஸோ அதனால திஸ் இஸ் அ ரைட் திங். ரைட், இது ரிடாக்ஸ் ரியாக்ஷன் நம்மளால சொல்ல முடியும். ஆனா அதுக்கான ரீசன் இதுவா இருக்க முடியாது. ஸோ த ஆப்ஷன் இஸ் A is true but R is false. Right? That's the thing. A is true but R is false. Okay? Then, yes. Carbohydrate digestion mainly takes place in small intestine. நம்ம சாப்பிடுற கார்போஹைட்ரேட், நம்ம சாப்பாடு சாப்பிட்றோம் இல்லையா, அதோட டைஜஷன் பெரும்பாலும் எங்க ஸ்மால் இன்டெஸ்டைன்ல தான் நடக்கும். ஆமா, ஸ்மால் இன்டெஸ்டைன்ல தான் நடக்கும். Pancreatic juice contains enzyme lactase. Pancreatic juiceல வந்து ஒரு bunch of enzymes இருக்கும். அதுல lactase இருக்குமா என்னன்றது I'm not sure. Let me check. No, it contains lipase, protease and amylase only. Just check it over. Right? So this option is wrong. So option C is the right answer here, right? R is false. So I had gone for biology, it seems. Okay. Budurapamma, you have to give the answer for this question. Four the answers only. First, Tamarai. Substance X is coated is used for coating iron particles. இரும்புல ஒரு சப்ஸ்டன்ஸை தடவுவாங்க. அது என்ன பொருள்? இரும்பு துருபிடிக்காம இருக்கிறதுக்கு. எஸ், எக்ஸாக்ட்லி, ஜிங்க். ரைட். இப்போ ஃபார் இன்ஸ்டன்ஸ் இந்த ஒரு வார்த்தையை வச்சு நான் என்ன எடுத்துக்கிறேன்? இது வந்து ஜிங்க்னு எடுத்துக்கிறேன். சரியா? அண்ட் the substance X is used for coating of iron particles is added to blue solution of reddish brown metal Y. Blue solution of reddish brown metal. Adana blue solution of reddish brown metal. Yeah, exactly. Yes. Appa Zn plus CuSO4 copper sulfate solution. Reddish brown metal la copper. சரியா? Gets discharged. The color of the solution gets discharged. Adi abdi. Yeah, exactly. Super. Displacement reaction. The zinc enna பண்ணும்? Zinc is highly reactive than copper. அப்ப என்ன பண்ணும்? It displaces copper. அப்ப it gives Cu plus ZnSO4. Right? That is why the color gets discharged. Type of the reaction. Now the answers are there. What is it? This is a displacement reaction and we had written the equation also. Right? Is that clear? Right. That is what they had given. Section B. Section C. Yeah. Identify the type of chemical reaction of the following statements and define each of them. Digestion in our body, rusting of iron, Heating of manganese dioxide with aluminum powder. What is a type of reaction? They asked about the type of chemical reaction. Digestion in our body. Decomposition reaction. Breaking down of larger particles into smaller particles. Na? So we are eating food in the form of rice or something, but that has been broken down. So it's a decomposition reaction, right? A single compound breaks down into two or more elements. And rusting of iron is nothing but oxidation reaction. We know that already. Denotes gain of electrons or loss of hydrogen. And heating of manganese dioxide with aluminum powder is a single displacement. Let me write the equation. Manganese dioxide, that is MnO2 plus Al, gives Al2O3 plus Mn. You have to balance this equation. So what happens here? Al has taken the place of Mn. So heating of manganese dioxide with aluminum powder is a single displacement reaction. A reaction which is more reactive element displaces less reactive elements. So this is called a single displacement reaction. Right. Okay, that's it. This points also we have to note down. Here Al is used as a reducing agent. Yeah, I had missed one thing. What I missed? M1O2 plus Al gives M1 plus Al2O3, but heat is also produced here, right? So what happens here? The M1O2, the M1O2 has become M1. So what happens here? Reduction takes place. So oxygen has been removed from manganese. So who helped for the removal of oxygen? Al. So that can be called as a reducing agent, right? And Al is more reactive than Mn. Make a note in your mind. Mark anywhere. Al is more reactive than manganese. Aluminum is more reactive than manganese. Yes. In the following diagram, for the preparation of hydrogen gas, as shown below, what would happen if the following changes are made? Let us observe the diagram first. Right. So this is the diagram given in your book. Right. So what happens here? We are placing the zinc granules here. We are placing acid here. So what happens? So let us write the equation simply here. That is Zn plus HCl gives ZnCl2 plus H2. Right? If you balance this, 2HCl, so 2 hydrogen, right? So this is the equation, right? So hydrogen will be produced and this will be colored, collected by here, and that will be tested by lighting a burning candle. So hydrogen is highly inflammable. When the soap bubbles comes out, if we bring the candle near the soap bubble, it will break with a pop sound. That indicates the presence of hydrogen, because hydrogen is highly inflammable, right? So in the place of zinc granules, so we are making changes here. So we can place zinc in the place of zinc granules. Some amount of zinc dust is taken in the test tube. Granules in the sense it will be like this, small particles. Dust in the sense it will be very small particles and the granule. Dust means powder. Powder. What we are using, that is called dust. Dusting means powder. So in the place of granules, if dust is taken, what will happen? The reaction will be much faster. Yeah, the reaction will be much faster, right? That is one point. In the presence of dilute sulfuric acid, dilute hydrochloric acid is taken. Right, dilute hydrochloric acid is taken. So sulfuric acid is nothing but H2SO4. Hydrochloric acid is nothing but HCl. So both the acids do the same work. They provide H plus ion. They provide H plus ion. That is the role of the acid. And in the place of zinc, copper turnings are taken. So instead of zinc, if we add copper, whether the reaction will take place or not. Why? Exactly, super. Copper is very less reactive. Zinc is highly reactive. That is the thing. Okay, let us check the answers here. Yeah. In the place of zinc granules, if you use zinc dust, the reaction speed increases. Yeah, what I said is right. The reaction speed increases. Instead of dilute sulfuric acid, if you use dilute hydrochloric acid, zinc chloride will be formed. So I thought that I made the equation for zinc hydrochloric acid only. Actually, they get given sulfuric acid. I thought that it's hydrochloric acid. I had made the equation for hydrochloric acid. So let us make the equation for sulfuric acid. So Z10 plus H2SO4 gives Z10SO4 plus H2. H2 evolves. Right? This is the actual equation should be written first. Right. So if we replace the sulfuric acid instead of HCl, what happens here? Zinc sulfate is formed. In the case of H2SO4, here zinc chloride is formed in the place of the presence of HCl. Right. And sodium hydroxide that takes place in the presence of sulfuric acid and the tube is heated. So when we use the sodium hydroxide, what happens? Sodium zincate is formed. This is called a sodium zincate. Yeah, they had written here itself. Sodium zincate will be formed and hydrogen is evolved. Right? Write this equation. This is sodium zincate. And then we shall move to the next question. Yeah, next, riddle. Interesting riddle. Right. Section D. Sahil bought X on electrolysis in aqueous solution produce a strong base Y along two gases A and B. Shahin bought a compound X. This X on electrolysis in aqueous solution produces strong base Y along with two gases. B is used in the manufacture of bleaching powder. B is used in the manufacture of bleaching powder. Identify X, Y, Z and chemical equations. Right. So if we consider bleaching powder means the formula for bleaching powder is CaOCl2. Note it down. CaOCl2. This is called calcium oxychloride. Calcium oxychloride. CaOCl2. Calcium oxychloride. Right. Now, Shahil brought a compound. Let us, if we consider this compound as sodium chloride, NaCl, right? This electrolysis in aqueous solution. Aqueous solution means it contains H plus OH minus. So this will produce NaOH, a strong base, plus two gases, chlorine gas plus hydrogen gas. Chlorine gas plus hydrogen gas. That's it. So here, when electricity is passed, through an aqueous solution of sodium chloride called brine, it decomposes to form sodium hydroxide. So this process, note down the name of the process, chloralkali process. Chloralkali process. And the products formed was chlorine and alkali. Chlorine alkali. That is chlorine and alkali. Chlorine and alkali. Chlorine and alkali. Yeah, this is the equation they had given. This is what I had written. So NaCl when electrolyzed, when treated with water, it gives NaOH plus Cl2 plus H2. Right? Chlorine is given off at the anode because Cl minus that will run towards a positive anode. So chlorine is liberated at the anode and the hydrogen gas that is plus H plus will run towards a negative cathode, right? And sodium hydroxide is solution is formed near the cathode. The compound X is NaCl, Y is NaOH, and A is hydrogen and B is chlorine gas. Chlorine gas, that is what I said. Chlorine gas is used in the manufacture of bleaching powder. Bleaching powder is produced by the action of chlorine on dry slated lime. This you can note down. Preparation of bleaching powder. Note down the equation that will help you. CaOH twice plus Cl2 gives CaOCl2 plus H2. This is calcium hydroxide and chlorine gives calcium oxychloride. We use calcium oxychloride plus water. So this is called the bleaching powder. CaOH twice plus Cl2 gives CaOCl2, calcium oxychloride. Calcium oxychloride plus water. Right? Next, another riddle. Raman took a sodium compound X, which is also used in soda acid fire extinguisher. It is in your activity. In your book, in last page, in one lesson, it is given the activity soda acid fire extinguisher. Unheated, it will use sodium compound Y along with water and carbon dioxide. Y crystallization forms compound Z. First, Raman took a sodium compound which is also used in soda acid fire extinguisher. That compound X unheated gives a sodium compound Y along with water and carbon dioxide. Right? Hmm. Here, it should be a carbon dioxide. It evolves carbon dioxide. That must be a carbonate salt. Right. So, which carbonate salt is used in the soda acid fire extinguisher? Normal carbonate salt. That is sodium hydrogen carbonate. So, sodium hydrogen carbonate. The X is sodium hydrogen carbonate. It is used in the fire extinguisher. Note it down. Fire extinguisher. NaHCO3. Sodium hydrogen carbonate, NaHCO3. That is used in the fire extinguisher. CO3. So then, when the compound is heated, when the sodium hydrogen carbonate is heated, it gives sodium carbonate, water, and carbon dioxide. Right? It gives a sodium compound Y along with water and carbon dioxide. So this is Y. So sodium hydrogen carbonate, when heated, sodium carbonate plus water plus carbon dioxide. And Y on crystallization, that is sodium carbonate on crystallization forms washing soda, sodium carbonate dot 10H2, washing soda. Okay, how can we obtain Y from Z? Y is nothing but here, this is sodium carbonate, and Z is nothing but sodium carbonate decahydrate. So, what is the difference between these two? What is the difference, Pa? Water molecules. So, what we can do? Yeah, by heating, by simply heating, these water molecules get evaporated and we can get sodium carbonate. Right. Right. Any two uses of the compound dessert. Compound dessert it we get identified as washing soda. So washing soda is used for yes, and also it is used in the manufacture of sodium compounds such as borax, and it is used for removal of permanent hardness of water. Two things we are using here. That's one.